Let us solve the equation x square into y minus 1 plus y square into x minus 1 equal to 1 in integer. So we want to solve this equation. Let's write this equation as equation 1 and we want to solve it in integer. Observe that if you take x equal to 2, if x equal to 2, comma y equal to 1, then you get 0 plus 1 square into 2 minus 1 equal to 1. That is 1 equal to 1. So clearly x equal to 2 comma y equal to 1 is a solution. Further that if you interchange x and y, then you get the same answer, right? The left hand side do not change. Therefore x equal to 2 comma y equal to 1 and x equal to 1 comma y equal to 2 are solution of the given equation. So we obtain the trivial solution. Do we have another solution? Maybe yes, maybe no. But what we observe is that if we take x greater than or equal to 3 and y greater than or equal to 3, definitely left hand side is much greater than or equal to right hand side. Further, we assume comma x is greater than or equal to y, because we can interchange x and y. If y were greater, then we can, by interchanging we can obtain that x is greater than or equal to y, and from one solution we can obtain other solution by just interchanging x and y. Next, we write the equation 1 once again. X square into y minus 1 plus y square into x minus 1 equal to 1. You see that this quantity is negative, sorry, minus 1 is there, and then also it's we have x minus 1 and here we have y minus 1. Let's change it by, let's say, v, and let's change it by u. So we are introducing new variables u and v. We want to replace x and y by new variable u and v. That follows that x equal to u plus 1 and y equal to v plus 1. Let's substitute those values in equation 1. So substituting x equal to u plus 1 and y equal to v plus 1 in equation 1 we obtain. You see that in equation 1 we have x is square into y minus 1. So x equal to u plus 1. So u plus 1 whole thing is square. U plus 1 whole thing is square into y minus 1. Y minus 1 equal to v. So u plus 1 whole thing is square into v. Similarly, y square, y equal to v plus 1. So v plus 1 whole thing square into u equal to 1. Now we see that this is of the type a plus b whole thing square. We know that formula that a plus b whole thing square equal to a square plus 2ab plus b square. V into v as it is. Again, a plus b whole thing square equal to a square plus 2ab plus b square. Now we see we can multiply it out by applying distributive law. So we obtain u square into v plus 2uv plus v square into u plus 2uv plus u equal to 1. Now you see that we can get something like u plus v common. So we write these two again, u square v plus v square u separately, and then u plus v separately, u square v plus v square u separately, and then plus u plus v, these two separately. Lastly 2uv plus 2uv, that's equal to 4uv equal to 1, copy as it is. Now if we can take u plus v common. When we take u plus v common, you see that we will be left out with uv into u plus v is u square into v plus v square into u, yes, plus 1 plus 4 times uv equal to 1. But you see we want to factorize this expression on the left hand side, but you see we have uv and uv here, but not just uv, but we have uv plus 1. See, you have uv plus 1. How can I get uv plus 1? Just add 1 to this quantity. So We get UV plus 1 common. But once we add plus 1 to the left hand side, we should add plus 4 to the right hand side to maintain the equality. So we maintain the equality. Now once again we can take UV plus 1 common. Let's take it common. And then we are left out with U plus V plus 4 equal to 5. Now you see that product of two integers. See, x and y are integer. If x and y are integer, we want to solve the integer x and y. Then u and v should also be integer, because integer minus 1 is again an integer. Integer minus 1 is again an integer. So uv plus 1 is also an integer. U plus v plus 4 is also an integer. Therefore, product of two integer equal to 5, but 5 is a prime. So 5 is having a limited number of factors. So uv plus 1, I have got limited choices. Once again, we see that uv plus 1 is a factor of 5. So possible choices of uv plus 1 are 1 minus 1, 5 minus 5. Let's write it down. Possible choices of uv plus 1 are 1 minus 1, 5 minus 5. Now, if uv plus 1 is 1, u plus v plus 4 must be 5, because product is equal to 5. U plus v plus 4 equal to 5, because product is equal to 5. If it is minus 1, then it is minus 5. It is 5, then it has to be 1. If it is minus 5, then it has to be minus 1. So from there, definitely we can find uv equal to, just subtract 1, 0, and minus 1 is minus 2, 5 minus 1 is 4, minus 5 minus 1 is minus 6. What about u plus v? Just subtract 4. 5 minus 4 is 1, minus 5 minus 4 is minus 9, 1 minus 4 is minus 3, minus 1 minus 4 is minus 5. Out of this, you see that product of two integer equal to minus 2, and their sum is minus 9. You see, if product equal to minus 2, u and v are factor of minus 2, and sum equal to minus 9, that's simply not possible, because factors of minus 2 are plus minus 1 and plus minus 2 only. So this case is not possible. What about this one? Product equal to 4, so u, v can be both plus 2 or both minus 2. In any case, u plus v is not equal to minus 3. So this case is both can be plus 2, both can be minus 2. Further, one might be 4, other might be 1. 4 and 1, yeah, minus 4 and minus 1. In any case, you see that this is also not possible. If 4 and 1 will give you 5, minus 4 and minus 1 will give you minus 3. What about this one? uv equal to 0, u plus v equal to 1. Now let's recall that we are assuming x is greater than or equal to y, that is x equal to u plus 1, correct? X is u plus 1 is greater than or equal to v plus 1. That follows that u is greater than or equal to v. Now product is 0, sum is 1. So that's only possible if one of the u or v is 0. So we are in this case 1, uv equal to 0, u plus v equal to 1. Definitely we are bound to take u equal to 1, v equal to 0, and otherwise so u equal to 1, v equal to 0, but u equal to 0, v equal to 1 we cannot take, because u has to be greater than or equal to v. So that's the only possibility. Case 2. uv equal to minus 6, u plus v equal to minus 5. So you see that you can take u equal to 1 and v equal to minus 6. 1 into minus 6 is minus 6, and 1 plus minus 6 is minus 5. But you cannot take u equal to, you have to take u greater than or equal to v. So yes, that's the only possibility. Therefore, in case 1, if you see u equal to x equal to u plus 1, therefore x equal to u plus 1, 1 plus 1 is 2, and y equal to v plus 1, v plus 1 is 1. In this case, x equal to u plus 1 is 2, and y equal to v plus 1 minus 6 plus 1 is minus 5. So finally we see that we have x comma y equal to 2 comma 1 and 2 comma minus 5. Further, we can interchange it as we have observed in the beginning. If 2 comma 1 is a solution, and then 2 comma 1 is a solution, then 1 comma 2 is also a solution. 2 comma minus 5 is a solution, then minus 5 comma 2 is also a solution. Those 4 pairs of solutions are obtained in integer, and we don't have any other solution.